Welcome to Mitchell Maths. In this video we're going to have a look at reflections. Reflections is one of three transformations you need to know. The others are translations and rotations. In this video we're going to be looking at how you can reflect lines in either x equals or y equals, and we're also going to have a look at what happens when you reflect shapes in diagonal lines, and also how to identify reflections. Right, so the first question is, reflect shape A through the line x equals 1. The first thing you're going to probably want to do is draw the line x equals 1. Well, x equals 1 here, and if you're going to draw an x equals line, it's going to always be vertical because you need to draw it along. Because anywhere on this vertical line, x is equivalent to the value of 1. If it had been y equals 1, you would have drawn a horizontal line starting here and going across. Now we need to reflect shape A in that line. What I'm going to do is I'm going to take a point and I'm going to count the number of squares to the line x equals 1, 1, 2, 3, 4, and then I'm going to move the other side 1, 2, 3, 4, and that tells me where that point is going to be in the reflection. I can do it for other points as well, and eventually at some point you'll get enough points that you can see how the shape is going to be drawn. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's going to be there. And this point here is going to be 7. And it's going to be 1, 2, 3, 4, 5, 6, 7. It's going to be there. If you did the point here, it's going to be 7 to it and 7 across. And you can just keep on filling in the points, and you will... And then you just join the points up as shown in shape A, and do remember to label it as shape B as the question that asked you to do that. And that's it. Right, let's have a look at a bit more tricky ones. So this is reflect shape A through the line y equals x. First we're going to draw y equals x, which is a diagonal line going this way. So if I just draw the dotted line. And what I need to do here is, I'm not going to be counting like squares vertically or horizontally. I'm going to need to go diagonally. So if we have a look at this point here, we can see if we go diagonally to y equals x, it's 1, 2 squares there. Therefore, we need to go and count 2 squares on the other side. 1, 2. So that point would be here. And this point here would be 1, 2, 3. So it's 3 squares to y equals x. 1, 2, 3 out the other side. That point would be placed here. And this point here would be 1, 2, 3, 4. 1, 2, 3, 4. It's going to be placed here. And now I can just join the dots to form the triangle as shown on the next slide. And do remember to label it B. So that's what you do when you've got a diagonal line, you need to count squares diagonally. When you've got horizontal or vertical lines, you could just count across or up and down. Describe the transformation of shape A onto shape B. The reason we know this is a reflection, it's not a translation because we can see the shape hasn't stayed in the same orientation, which means it must be either a rotation or either a rotation or reflection. And the reason we can see it's not being rotated is because, like if we think about shape A, if that was going to be rotated, well, if we it's like that, and then if we rotated it 90 degrees, it would look like that. Then if we rotated it 180, it would be like that. And then could have been like that. So we can see it's not in the right orientation to be rotated. Now we know this. What we can see from this graph is that it's been reflected diagonally. It hasn't been reflected horizontally or vertically, so it's not a y equals you know, like y equals 2, for example, or x equals -1, because it's gone diagonally. And because it's been reflected from this positive quadrant to this negative quadrant, we can see the diagonal line must have gone across y equals -x. And if I just draw that dotted line, we can just check, confirm it. Let's have a look at this point here. 1, 2, 1, 2. Okay, that fits in with it. We'll check another point here. 1, 2, 3 and a half. A half, 1, 2, 3. It comes here. So you can check with as many points as you like, but we can see it's quite obvious. The shape here has been reflected in the line y equals x. So we just write reflection in the line y equals -x, and that would be your answer. So yeah, you can you just need to look, is it being reflected diagonally? Has it been reflected vertically or horizontally? And then find your line. Right, thank you for watching. Hope you found that helpful. If you liked the video and like to see more, please hit the subscribe button. For practice questions, please visit www.mitchellmathsandscience.com. The link is in the description.